Hi everyone, welcome back to the channel and welcome back to the brand new course on DP-600 Microsoft Fabric with real world project. And we are in module 2, preparing and serving data, and in this video we'll dive deep into the monitoring tools that you can look at in Fabric and also the performance optimization techniques across different components in Fabric as well. And if you're new to this channel, let me introduce myself. This is Sheikh Mohammed. I'm an Azure Solutions Architect and Fabric Analytics Engineer. I have close to 15 plus years of work experience in IT. Let's dive into the roadmap. We'll quickly look at the roadmap. So we are building a 10-part video series around DP-600, and the goal of this course is to provide you with as much hands-on as possible. And we are building this course around real-world dataset, which is COVID-19 dataset. And if you haven't looked at my previous videos, I would encourage you to look at my previous videos to go through the COVID-19 dataset that we are looking at as a part of this course. And we also completed module 1, wherein we looked at planning, implementing, and managing data analytics environment and how you can manage your analytics development lifecycle and the data ingestion concepts and shortcuts and all those concepts as well. In video 5, we also looked at the transformation of COVID-19 dataset and then how you can organize your data using medallion architecture and the basics of star schema and type 1, type 2 SCDs. So we looked at all of those concepts in detail in video 5. And without any further delay, let's dive deep into this video, wherein we will look at how you can identify the performance bottlenecks across components in Fabric and how you can use different techniques to provide resolution for those bottlenecks as well. Okay, and let me quickly take you through the Google Classroom community, and you can, whatever resources or artifacts we'll be creating as a part of this course will be uploaded into the Google Classroom community, and you can find the link in the description of this video. Let me quickly take you through the Classroom community real quick. So there you go. So we have this classroom, DP-600 Fabric Analytics Engineer, and you can see in the stream the posts or announcements that I post whenever a new video is out, or all of the resources you can find there. And under classwork, you can see all of the DP-600 course materials that we are creating as a part of this course, the PySpark notebooks and the official study guide links and COVID-19 public dataset links. And if you're following along, I would encourage you to raise a request and join this community, and you can download the notebooks and look at other resources that I'll be sharing in this community. Okay, let's look at the performance optimization matrix that I have here. So the idea here is to expose you to different tools that we need to use in Fabric to identify the performance bottlenecks, be it Dataflow Gen2 component or Spark notebooks or SQL queries. So I have provided the distinction here across different components. What are the different tools that you can use in the Fabric to identify the performance bottlenecks, and the resolution part, what are the different techniques that you can use to provide resolution for those bottlenecks as well. That's the idea. So I thought it's easier for you to understand with this matrix. We will quickly go through this in brief, and then probably we can jump onto the Fabric portal to look at different tools that you can use for identification across components, and then we can talk about techniques, and then we can also go through some of the Microsoft documentation to expose you to different techniques that you can use for providing the resolution when there are performance bottlenecks as well. Okay. So let's look at it in brief. So Dataflow Gen2, I think monitoring tool, it is not specific to one component. You can use across all the components. You can look at the monitoring tool, and then you can navigate to the Spark history server, or you can look at the refresh history for Dataflow Gen2 as well. So let's talk about Dataflow Gen2. I will take you through the monitoring tool, how we can use the monitoring tool in the Fabric to track the activities that we are performing in Fabric. Okay, So monitoring tool is one thing you need to know, and you can also look at the refresh history in Dataflow Gen2 and look at the details. Maybe I will show you shortly the refresh history for one of the Dataflow that we have executed. And notebooks, you can navigate to Spark history server, and then you can look at the DAG and the job details to identify if there is any performance bottlenecks, the job level. And you can also look at the executor metrics there, and I will also take you through the Fabric capacity metrics app. So there are a couple of components are there. You can look at the compute as well as storage in the capacity metrics app, which will come in handy whenever you need to identify if there is any resource consumption that you need to look at if it is really intensive. And SQL queries, we have the dynamic management views. So one example is you can what we're having here is DM execution query stats. So probably I will take you through some of the DMVs that you need to know to be able to identify the long running queries, be it or frequently running queries. So you just need to know, and then Fabric is already providing the abstraction for you to look at the query insights. So we will go through that as well. And you can look at the query execution plan to identify the actual execution plan, and then try and identify if there is any need for index to be created. In case of complex joins, you can optimize those as well. And we'll talk a bit about techniques, but I think we can look at the tools first for identification, and then we can jump onto techniques, and then we'll talk about each and every technique, be it Dataflow Gen2 staging, fast copy. In my previous video I provided a demo. We'll probably quickly look at it in brief. And the applying incremental refresh, which is currently in preview in Dataflow Gen2 to improve the performance without doing a full load. And you can also push the filters early to reduce the rows processed. Okay. And notebooks, obviously the data partitioning will come in handy for parallelism. So we already looked at it for our COVID-19 dataset. To partition the data from when we write to the goal layer, we partition the data based on location. So that we can look at quickly as well. And the broadcast joins in case of smaller data sets without or avoiding shuffles when you're performing join to a larger data set. And if the data set is like dimensions, if it's small, you can broadcast it to different nodes across the Spark cluster. So that is an optimization technique that you can use. And you can, this is very important, you can enable optimized writes and VORDER for delta tables, okay, in Lakehouse. So that is enabled by default, but you need to know what is VORDER clustering or what is optimized write for delta tables, and what it is doing and how it is helping to optimize the writes to the delta tables in Lakehouse as well. Okay, so we'll go through that. And SQL queries optimization, as I mentioned, you can look at the execution plan and then fine tune by creating the required indexes, right? So that will come in handy to optimize the performance in case of SQL queries that you are having complex queries and complex joins. Definitely there are opportunities to look at the indexes, right? So whether you have created those indexes correctly. So the way we can do it or identify is with the help of the execution plan that you can look at, right? And you can also use temporary tables and apply filters early to narrow the data set further on, okay, as and when we progress or process the data further. So those are all the key ideas as a part of this video. With this brief, I think we'll jump over to the Fabric portal to look at the identification tools first, each and every tool, and then we'll talk about techniques using the Microsoft documentation, and even with the COVID-19 dataset, what are all the techniques like fast copy in Dataflow Gen2. It's enabled by default, and what happened to the COVID-19 dataset, because it's of minimal size, which is 5 MB, and they have a threshold limit. Only when it reaches a threshold limit, you can the fast copy will be enforced, you can say. So we'll look at all of these in this video, and let's jump to the Fabric portal right away. Let me come back to the Fabric portal. So we'll look at the monitoring tool as I mentioned earlier on. Let me navigate to, so you can see here, once you click on this three dots, there are different things you can pin. Okay, and if I can navigate to monitor section, there you go. You can see all of the activities that we performed recently in Fabric workspace, and you can see the item type, beat, semantic models or notebooks. So all of the activities will be listed here with the status, whether it is successfully completed or failed. From there on, you can navigate to Spark history server in case of notebooks. So we will look at it as well. So this will give you even different controls to enable different columns as well. If you need to add more columns to this view, you can control those as well. Okay, and even you can filter the list here based on the job succeeded, failed, or in progress. So all of those controls are provided here in the monitoring tool for you. So maybe let's look at the notebook. So here you can see the Spark application. So let me click on this already executed notebook. Okay, Spark application. If I click on that, so you can see the different jobs that we executed as a part of this particular Spark application or the session that got initiated. So you can look at the run details here, how long the total duration the session was active. You can see the application ID, the run duration, and you can see the runtime as well, Spark 3.4 and the Delta 2.4, and the configuration as well, like driver cores, driver memory, 8V cores, executor cores, other information as you can see here. Right? But if you want to look at more details about these jobs, what you can do is you can navigate to the Spark history server itself. That will take you to a different tab. So let it load. So here you can see that particular application ID and the Spark session that you can see here. If you need to look at this particular session in detail, you can always go to that particular application, look at different jobs, like 84 completed jobs that you can see here. And you can also look at the stages, environment, and other information as well. And if you need to drill down to a specific job, you can also do that and look at the DAG as well. The visualization would be there. So if there are failures or if the job is taking too much of time, you can always come to the Spark history server and drill down to the lowest level, and then you can try and identify the problem or fine tune as well. Okay, so let me close this and let me go back to the monitoring tool. Close this as well. Go back to monitoring tool. So similarly, I think if you also need to look at different item types, you can do that. So you can see here the data pipeline, Dataflow Gen2 we have for COVID-19 cases. You can also look at the historical runs for those. You can look at the details here as well. Okay, but for Dataflow Gen2, let me take you through quickly the refresh history, right? So you can come to the workspace, DP-600 course workspace, and for this particular data flow, you can look at the refresh history as well, right? So once you click on refresh history, you can see the last refresh, and when you click on that particular refresh, you can get more details about what are all the activities that got executed as a part of this refresh. So we wrote the data to the destination, and you can see there is a warning. I talked a bit about fast copy in the previous video. There is a threshold limit. Only when it reaches that limit, it will kick in. Otherwise, for COVID-19 dataset, it's a minimal dataset, so it's just giving a warning. It's not applying fast copy. So maybe when we get to it, I can show you, maybe give you a brief about fast copy when we talk about the techniques. So let's look at the tools first, and then we can move on to the techniques, and then we will touch a bit about fast copy as well. Okay? So which is a very interesting feature provided in Dataflow Gen2. So under the hood, it it utilizes the data pipeline copy activity to help you with ingest terabytes of data, and they have a threshold limit. If it's a smaller data set, it won't be applied, even you can control the fast copy as well. Okay, so we'll look at it shortly. So refresh history, you can look at if there is any issue during the Dataflow Gen2 execution, and then you can try and identify the problem accordingly, right? So let me also take you through the Fabric metrics app, capacity metrics app. So for that, let me come to apps here, click on apps. So here you can see Microsoft Fabric capacity metrics app already installed, right? If you don't see this, all you can do is you can click on get apps. That will take you through here, and you can go and install the Fabric capacity metrics app. Okay, that's it. So just click on the Fabric capacity metrics app. So here, as I mentioned, there are a couple of tabs that you can see, or pages you can see. One is compute and storage. So let me probably minimize this and zoom in a bit. Review. So there you can see under the compute, you can see the trial account that is attached to the capacity, and you can see probably the different options for users, operations, duration, or capacity units. How many, capacity units, the usage of capacity units for our workspace. So there you can see different components or items, and the usage accordingly here to track, and the utilization also you can keep a track here, and if there is overage or other information you can look at here with respect to the compute. Okay, so here if you just scroll down, you can also see the items or the workspace that is consuming more capacity units, right? So you can see the workspace DP-600 cores. This particular item, which is ECDC cases transform notebook, is consuming this much of capacity units, and the duration and the users and other information you can see here. Okay, so the compute usage, you can come to this capacity metrics app and you can have a look and identify if there are any items that is kind of intensively consuming resources. You can identify those from this app itself. And you can navigate to storage as well and look at different workspaces consumption as well. Here you can see my workspace consuming significant storage, close to 7.54 gigs. Okay, and DP-600 cores, very minimal, only few artifacts we have. You can look at the storage as well, and across workspaces you can also filter by date range and look at the billable storage and other information as well. Okay, that's the idea. I think you can go back, click on go back. That will take you to the apps. Okay, and even you can look at other apps if you want to install from within Fabric. You can install those as well. So from identification point of view, we looked at the monitoring tool, capacity metrics app. We looked at refresh history, and what else? We looked at Spark history server. In case if you need to identify any bottlenecks in any of the jobs, you can navigate to history server, and then you can look at different jobs and then try and identify the problems there, right? Let me come back to the presentation. So we will quickly look at the DMVs as well. Okay, so and the query insights with respect to SQL queries. What are all the DMVs that you need to know? So let me quickly take you through those as well. So here I'm in Microsoft documentation, so I will make sure to provide all of this documentation links in the Google Classroom community for you to look at all of these details as well for all of the DMVs, but it's quite a lot. But we will look at the DMVs used to provide the abstraction for you to look at the query insights, for example, the long running queries and frequently running queries like those. So here I think you can see all of the execution related DMVs, dynamic management views, that helps you to identify or spot any long running queries in case if the query is taking longer, let's say. So here you can see a ton of DMVs. This is execution related, but you can see there are a lot of other DMVs that are available. We are not going to look into those. Even in execution related DMVs, I wanted to focus on few of the DMVs like the DM execution query stats, DM execution requests, that will give you. So let me click on that particular DMVs. So you can go through the information. So it returns the information about each request that is currently being executed in SQL Server, right? And you can look at the different columns that it returns. Okay, the session ID, request ID, the status, okay, whether it is running or sleeping or suspended, okay, and the command as well. So here you can see it will just it will be providing just the command, like whether it is a select command or insert command or delete, update commands, okay. But if you need to look at the actual query that got executed, so you need to be able to use another DMV, which is DM execution SQL text, with the SQL handle that you'll be getting here, right? There will be a handle that you need to pull and then provide it to this DMV to identify the exact text or the SQL query that is having a problem. Okay, so there are a lot of DMVs involved, but we will quickly touch upon few, like the execution requests, execution sessions. That will give you the authenticated sessions on SQL Server. Okay, it returns one row per authenticated session. So you can look at the active sessions at the moment in the SQL Server as well. Okay, you can go through the details. I'm not going to get into each and every column on the information, but these are all useful DMVs you need to know. And Fabric is already providing abstraction for you to look at the query inside. So we will quickly look at that as well. Okay, so DM execution SQL text, you can pass the SQL handle from the execution request and then look at further information there. And there are many other useful DMVs, dynamic management views, that you can use to identify if there is any performance bottleneck with respect to the SQL queries that you'll be executing. Okay, so that's the idea. So if I go back to the Fabric portal, let me come back to the workspace, DP-600 workspace. Let me open the COVID Lakehouse. So what we'll do is we are in a Lakehouse view here. As you can see here, the tables and files view. But what I'm going to do is I'll navigate to the SQL Analytics endpoint so that you can query the data, okay, using the SQL queries. So now you are seeing a different view, right? So here you can see the schemas, queries that you are executing. Okay, you can create new SQL query and then query the data in the Lakehouse. So if I click on schemas, okay, there you can see the list of tables that we have. And let me minimize the DBO schema. Here you can see there is a separate schema called query insights. So that's the abstraction that I talked about, that Fabric is providing to you already. Okay, abstracting those dynamic management views already for you. So there you can see the execution requests history view already abstracted for you from the DMV we just looked at, and the long running queries, frequently running queries, and then the execution sessions history as well. Okay, you can always look at the information, like if you want to look at the long running queries, just click on it. It is already abstracted for you. You can identify the problem queries and then try and fine tune further by looking at the execution plan as well. Okay, there you go, we got it. So here you can see the data preview for the long running queries. You can see the median time, last run time, okay, start time, then the statement IDs. You'll have other useful information here, the query handle, that query hash, and you can see the last run command information as well. Okay, so you can, based on the timings, okay, the last run, total elapsed time, that's the metric that you need to look at in case of long running queries. What is that query that is taking longer, and then look at the execution plan further, and I try and fine tune the query or create the required indexes, and then rerun and check, fine tune and check if the query is performing better as well. So those are the abstractions I wanted to show you, the frequently run queries as well. Then you can look at the sessions information, the requests we talked about. Let me quickly show you the preview. So here you can see the requests history, the total elapsed time, the login information, okay, and then the row count, whether it has succeeded or not, the session ID, the program, and other information, useful information that you can see here, and a query hash and the other information. Okay. So that's about query insights and the required DMVs that you need to know. So I'll be sharing the link to the Microsoft documentation. You can learn more about different DMVs if you want. Okay, so now we already looked at the tools that you need to know to identify some of the performance bottlenecks across different components like the Dataflow Gen2, notebooks, and SQL queries. Now let's talk about the techniques for resolution. So let's talk about the Dataflow Gen2 staging, fast copy quickly, and then the applying incremental refresh in Dataflow Gen2. And with respect to notebooks, we already looked at partitioning, but we'll talk a bit about it. The broadcast joins, as I mentioned, and then we will talk about optimized writes and reordering for delta tables. Okay, so let's look at it one by one quickly so that you will get an idea. Let me come back to the Fabric portal. We open the already existing data flow, the DF for COVID-19 cases. So here in this data flow, I think what you can see here, just wanted to show you, there are, to right click, you can see quite a few options like enable staging, incremental refresh. I think it's in preview, public preview at the moment, I guess. So we'll look at it, and then the require fast copy. So we will talk a bit about all of these three settings quickly. So let me navigate to this blog from Microsoft Fabric about the incremental refresh, which is in public preview at the moment. So the idea here is to ensure that only the data that has changed since the last refresh is updated. Okay, so that will improve the performance. So that's the key. And once, when you're trying to enable this option, you will have this window for you to set up or provide some configuration here, because you need to set up the filter, okay, the filter column, which column you need to choose, that particular date or daytime or daytime zone column to filter by, and the extracting the data from the past. In this instance, it's 2 weeks, and then the bucket size and other configuration that you need to do to enable the incremental refresh in Dataflow Gen2. Okay, so it's quite easy to set up. So if in case you know the data is changing frequently at the source, you can configure the incremental refresh to improve the performance of Dataflow Gen2. Okay, then let's talk about fast copy. So as I already mentioned in my previous video, we did a demo on that as well, and you can I would encourage you to watch that as well. But in brief, I can quickly provide you a brief information about fast copy as well. So I think this is not enabled by default here, so you can enable the require fast copy, and the idea here is it will try under the hood to use the data pipeline copy activity in case of large data set that you're trying to process. There is a threshold limit. I talked about it in detail, so which is close to 100 MB. So only when the data set size is huge, or if it's trying to meet that particular threshold, it will kick in, and then it will try to utilize the data pipeline copy activity to improve the performance under the hood, okay, in the backend. Otherwise, if the data set is smaller, I think it won't kick in, even if you enable this setting fast copy. So maybe let's quickly show you that. I come back to DP-600. Let's close this Dataflow Gen2. Let me go to the workspace, and then here you can look at the refresh history for this Dataflow Gen2. And as I already mentioned, you can click on this activity, and I think this is just a 5 MB file, the COVID-19 dataset that we are trying to process. So you can see here there is a warning. Even when we enable the fast copy, it did not kick in, since it's saying, you know, not applying fast copy for source below size threshold. So the bytes that we're trying to process and the threshold, as you can see, is way higher, right? So it's not meeting that threshold, the data size. Hence, it's providing a warning. It's not applying the fast copy. Otherwise, it will be providing that capability for you to improve the performance when you're processing your data in the Dataflow Gen2. Okay, so that's the idea about fast copy. Let me come back to the Dataflow Gen2. So we talked about incremental refresh, enabling incremental refresh in your Dataflow Gen2 queries. Okay, and also we talked about fast copy. So let's talk a bit about staging, why you need to enable staging, and how you can improve the performance when you're executing your Dataflow Gen2. Okay, so let me go back to one other documentation. Okay, so this is a Data Factory Spotlight. This article provides you useful information about how you can improve performance for your Dataflow Gen2 in Fabric. Okay, so let's look at the staging feature that will help you. We quickly come down or scroll down. So we'll quickly look at how we can controlling the staging for Dataflows Gen2. So what's the idea of staging here, right? So before you load your data into the final output destination, so you may want to stage your data in the lakehouse to improve the performance, right? And that you can do only when the data size is huge. So here they have listed few examples where you might not want to load data directly to the destination without enabling staging. So what are all those scenarios? If your data source does not contain big data volumes, or if you're not joining data from different sources, or if you're not performing memory or compute intensive transformations such as joining or aggregating large data volumes, right? In such a scenario, you may not want staging enabled, so you can directly write to the destination. Okay, but if you want to control staging, if the data size is huge, you can do that. We'll have a look at it quickly. So here they are providing a quick example when you're trying to load the data from a 100,000 CSV file to a Azure SQL database, right? So I think it's not required. So in this scenario, they're saying 100K records to my Azure SQL, and I would like to apply some few transformations like renaming and removing columns and filter out columns. But for these type of transformations in data volume, staging data is not required, right? So it's not massive data that we're looking at here. So you can disable the staging for any query by right-clicking the query and deselecting the enable load action. I think it's not enable load, it's directly you can enable staging or disable it by right-clicking a specific query, okay, in your Dataflow Gen2. So here there is this useful diagram. So what happens in case if you're not enabling staging? It will be this mashup engine is the Dataflow engine. It will be used directly to load the data from source to destination. In case if you are enabling staging, what happens is the data will be pulled and loaded into the lakehouse staging lakehouse. So I think in the backend it will create a separate lakehouse to store your data first, okay, and then optimize the data probably by partitioning the data. So it is completely abstracted, you no need to worry about it. So all this will be done in the backend, and once the data is loaded into the staging, and Microsoft is leveraging the Spark compute engine to speed up the process, the transformation process, and then finally load it into the output destination. So that's the difference when you're trying to enable staging or when the staging is disabled. And And please keep in mind, if you are enabling staging for smaller data sets, there would be a overhead. There could be overhead that could degrade the performance as well. So enable it only when it is required. So when the data size is massive, you can enable the staging for your Dataflow Gen2, and that will improve the performance for you as well. Okay. So that being said, let's go back to the presentation. So we looked at different capabilities or techniques that you can use to improve the performance of Dataflow Gen2, like be it fast copy or staging or incremental refresh, which is currently in preview. So let's talk a bit about if you are using Spark notebooks for your transformation, how we can optimize the performance. So in that case, I think we'll quickly look at the data partitioning, which we have already done for the COVID data. And then we will talk about the V-ordering and then optimized writes for delta tables. So let's jump back to the Fabric portal. So here, let me navigate, let me close this Dataflow Gen2. So let me open the notebook from the workspace, which is DC-DC cases transform. So we have already done some transformation in the previous video as a part of transform data, and then finally the gold aggregated data, we wrote it to a delta table. Let me show you that. So here you can see, so we already wrote the final gold data. After transformation, we wrote it to this table called COVID gold aggregated KPIs. And you can see here, we already partitioned at the time of writing by location key as a delta table, and then we loaded. Right? So here, if I can navigate to the lake house under tables, you can see the gold aggregated data, COVID gold. Let me expand this COVID gold aggregated KPIs table, which is our final gold table, okay, for further analytical process. Let me click on this 3 dots and look at view files. You can see the data is partitioned based on the location key already. Okay, so when we wrote it to the lake house as a delta table, we partition the data for efficient processing further on, right? By the downstream process. So that's the key, and data partitioning will come in handy. And I think there is this blog by Sally Daba. She talked about efficient data partitioning with Microsoft Fabric, best practices and implementation guide. So she did exactly the same. She talked about and she provided a bit of introduction about what data partitioning is. It's the data management techniques. So we are trying to shard or divide the data into more manageable chunks. The primary goal is to improve the performance and scalability and manageability in case of large scale or big data systems, right? So that's the key. And here you can, she provided a sample example with the yellow trip data, taxi data, and she did exactly the same that we have done in the previous video. While writing, she's partitioning by year, month and day, and you can see the in the lake house the data is partitioned by year, month and day, and then you can see the Parquet files loaded there. I'll provide the link again in the community. You can go through and also follow along if you want. Okay, so let me come back to the Fabric portal. So we talked about data partitioning. Let me take you through a couple of other techniques about how you can optimize the delta table, right? So there are a couple of techniques we need to know. Okay, so but it is enabled by default. I will show you from the Spark history server. It is already enabled. You no need to enable it. Okay, it's enabled by default, and if you want to disable it, I don't think there is a reason for you to disable. You know, it provides benefits when you're writing it to the delta table. So I think we can also look at the Spark configuration to show you those settings that's enabled by default as well. But let's try and understand these couple of techniques, the optimized write and V-ordering when you're writing to the delta table. So VORDER is nothing but a write time optimization. So I'm here in the Microsoft documentation just to quickly take you through to understand this concept. Okay, it's a write time optimization to the Parquet file format directly. Okay, so it's basically it's trying to apply some special sorting, right? So, and row group distribution and dictionary encoding and compression as well on the Parquet files. So you no need to dive deep into what's happening in the background as a part of reordering, but at a high level, just keep in mind it's applying special sorting and the compression techniques on the Parquet files when you're writing, thus requiring the less network and disk and CPU resources and compute engines to read it. So once it's returned into the lake house, then further on when the compute engines, when it's trying to read it, it will be much faster. So they are providing some metrics here. So the VORDER sorting has a 15% impact on average write times, but provides up to 50% more compression as well. Okay, so it improves the efficiency, okay, the cost efficiency as well as the performance as well. It's 100% open source Parquet format compliant. So all Parquet engines can read it as a regular Parquet files. So no need to worry about it as well. Okay. And how you can control this? So let me show you the configuration. Okay, the spark.sql.parquet.vorder.enabled is true by default. Let me show you. So let's open the monitoring tool real quickly. Let me open this Spark application. We will navigate to Spark history server quickly just to show you the configuration. So open the application. So navigate to environment, and you can see the Spark properties listed here. Let's do a quick search on VORDER, and there you go. There you can see the Spark SQL Parquet VORDER enabled is true by default. So I didn't set it explicitly. It is enabled by default for you when you are writing to your Delta files in the lakehouse. So it is enabled already for you, but you need to know what this technique is. From exam point of view, you need to know both of these techniques to optimize the Delta files, table files that we are writing to the lakehouse. Okay, and the second technique is, let me come back to the documentation. So that's how you can control the VORDERs technique. Let's talk a bit about, let me scroll down. Let's talk a bit about optimize write as well. Okay, so optimize write is another technique, so wherein it addresses the small file problem. So what is the small file problem? So when you're ingesting data into the data lake, right, so there are many characteristics which constantly write lots of small files. Okay, so it's possible, and this scenario is commonly known as the small file problem, they call it. Okay, and how we are trying to address with optimize write. Okay, so the big data processing engine like Apache Spark perform most efficiently when using standardized large file sizes, right? So a lot of too many small files will create a problem for the compute engine to read and process, and that's where the optimize write technique will come in handy. And how we are going to do it is optimize write in Delta Lake, and it's available in Synapse Analytics as well. Okay, in the Spark engine, that actually reduces the number of files written, and I think it's trying to, its aim is to increase the individual file size of the return data. So it will try to address the small file problem, and the target file size can be changed as per the workload requirements, but the idea here is to address the small file problem to standardize the file size itself. Okay, and again this feature is also enabled by default in Fabric runtime. You no need to explicitly enable it. Okay, but you need to know what this optimized write is as well. Okay, so let me come back to the Spark history as well. We just looked at the VORDER, which is enabled by default. Let's also search for the optimized write property. Optimized write, there you go. You can see there spark.microsoft.delta.optimized write.enable is by default true. So those are the couple of settings which you need to know to improve the performance when you read the delta files from the compute engines, right? So when you're trying to write to the lakehouse delta table, so you can partition the data and then you can apply this couple of, it is enabled by default, so you no need to worry. In Fabric it is already enabled, the VORDER clustering. It applies some special sorting and compression, and then the optimized write to address the small file problem as well. Okay, so let me come back to the presentation. So we so far looked at how you can apply different techniques in Dataflows Gen2 to improve the performance when you're looking at larger data sets, and also when you're using Spark notebooks, how you can partition the data for parallelism, and also we looked at optimized writes and VORDER for delta tables as well. Okay, so in case of SQL queries, how we can use different techniques to optimize the SQL query, right? So we looked at the tools or the DMVs that you can use to identify the long running query. So imagine once you figured out, okay, so there is a problem with the query, with the long running query. So you can also look at the execution plan, as I mentioned, right? So to identify where it is taking a lot of time, right? So which dimensional join or which join is taking a lot of time. So to drill down to a specific object, you can look at the execution plan and then look at it further and then try and identify if an index is required. So once you identify, even you can create a non-clustered index with the include operator as well to include a lot of the other columns that are involved as well. That will speed up the query processing as well. So that's the key here, is to try and identify if there are issues with index, even the execution plan, the estimated execution plan. Okay, so we'll give you some suggestions to create some indexes which are missing, or you can manually look at different joins and where it is taking a lot of time, and try and optimize further by creating the required indexes. Okay, so that's the key. And you can also use temporary tables and apply filters early, as we talked about, to try and minimize the data set later on during complex joins as well. Okay, so that's some of the techniques that you can use to create some indexes and also fine-tune the query itself to resolve the bottlenecks, if there are any bottlenecks with your long-running queries. Okay, thank you so much for watching. A quick summary. In this video, we looked at performance optimization techniques across different components like Dataflow Gen2, Spark notebooks, or SQL queries. So we looked at the tools required to identify the performance bottlenecks across different components. And then we looked at the different techniques for Dataflow Gen2. We talked about fast copy, incremental refresh, and also staging in case of larger data sets to optimize the performance of Dataflow Gen2. In case of Spark notebooks, we looked at the Spark history server, how you can navigate and identify the performance bottlenecks for different jobs that we executed by Spark cluster, Spark compute engine. And then we looked at different techniques like the VORDER clustering and then the optimized write to the delta table files, how we can optimize that. And also we looked at the data partitioning when you write to the lakehouse. And for SQL queries, we looked at different dynamic management views. So we looked at few of the dynamic management views, and then how Fabric is already providing the abstraction to look at the query insights in case of long running queries or frequently running queries, or the requests that are currently being executed, or the current sessions. So those are the different DMVs that you can use to identify any performance bottlenecks with your SQL queries. And with respect to the resolution, we talked about creating the required indexes by looking at the execution plan for your query and try and identify where exactly it's taking a lot of time, and then create the required missing indexes to improve the performance of your SQL queries. Okay, so I hope it's helpful. Thank you for watching. See you in the next one.